You know how your phone can stream music, navigate, and take a call all at the same time without even skipping a beat? Ever wonder how it actually does that? Well, today we're going to pull back the curtain on how your computer really gets things done. And to understand it, we're not going to talk about code or silicon. Nope, we're going to tell a story about a simple workshop. Okay, let's dive in.
It's honestly kind of hard to imagine now, but if you rewind just 2 decades, a computer with more than 1 or 2 brains, or processing resources, was this super rare, super expensive thing. That was the reality. And it really sets the stage for the absolute explosion in power and complexity that was just over the horizon.
Which brings us to right now. The phone that's probably in your pocket, it almost certainly has an 8-core processor. I mean, think about that jump from 2 being a luxury to 8 fitting in the palm of your hand. So why the massive leap? Why do we need so many? Well, answering that question is the key to understanding everything.
To really get to the bottom of this, let's just push aside all the jargon. You know, transistors, gigahertz, all that stuff. Instead, I want you to picture a small workshop, a joinery, where things get built from scratch. This little workshop and the people inside, they're going to be our guide to the incredible architecture humming away inside your machine.
So every workshop really revolves around its master craftsperson, right? The one person who takes all the raw materials and turns them into something useful. In our story, this person is our joiner. And this joiner, well, they're the heart and soul of the whole operation. In the world of computing, you probably know them by a more famous name.
Our joiner is the CPU, the central processing unit. Think of it as the main worker, the brain of the computer. Its control unit is the part that reads the blueprints, the work orders. And its arithmetic logic unit, or ALU, well, that's its set of power tools. That's what does all the heavy lifting, the math, the logic. The ALU is the part that's actually building things. Okay, so what does a day in the life of our joiner actually look like? Well, it's this crazy, non-stop rhythm. It's a 4-step dance that happens over and over, billions of times, every single second. It's truly mind-boggling.
So it all starts with fetch. Our joiner grabs a new work order from the main office. Then, decode. They look at the blueprint and figure out exactly what needs to be built. Next up is execute. They fire up their tools, that ALU, to cut, shape, and assemble the whole thing. And finally, store. They put the finished piece in the warehouse. Fetch, decode, execute, store. Again and again, faster than you can even imagine.
Now, our joiner is a total genius. I mean, unbelievably fast and efficient, but there's this one huge problem, a massive bottleneck that threatens to bring the entire workshop to a grinding halt. See, the warehouse, where all the materials are kept, it's a really, really long walk away. And this, right here, is the central drama in all of computing. It's a huge deal. You can have the fastest processor in the entire world, but that speed means absolutely nothing if it's just standing around waiting for the next piece of data to show up. It's like having a master chef who spends 99% of their day just walking to a pantry that's 3 blocks away. Okay, you have to see this to really get it. This slide translates that waiting time into human terms, and it is just wild. So let's say one CPU cycle, one thought for our joiner, is just 1 second, okay? 1 second. Now, getting a tool from their pocket, that's called the L1 cache, that takes 2 seconds. Not bad. But what about that walk to the main warehouse, to RAM? That's a 4-minute round trip. And if they need something from deep storage, from a hard drive, our joiner is gone for months. No joke. It is an absolutely astronomical waste of time.
Right. You can't run a business when your star employee has to take a 9-month walk just to get a screw. It's impossible. So engineers came up with this brilliant solution. Don't try to make the joiner walk faster. That's not going to happen. Instead, you redesign the workshop. You bring the work to the joiner.
And that solution is cache memory. In our story, this is the joiner's personal workbench. It's this small, incredibly fast, and yeah, pretty expensive bit of storage that's built right there on the CPU chip, right next to them. The system gets super clever. It starts to anticipate exactly what tools and materials the joiner is going to need next, and it preloads them right there on the bench. And this chart just shows you what a game changer that is. Grabbing from the L1 cache, the workbench, is that 2-second task. The L2 cache, let's call it a small shelf right behind them, takes about 7 seconds. But that walk to the main warehouse? Still a 4-minute journey. So that workbench, it's what transforms our joiner from being a professional walker into a master builder.
So, we've made our single joiner incredibly efficient. But the orders just kept getting bigger and way more complex. One person, no matter how fast they are, just wasn't going to be enough. The workshop had to grow. It needed a manager, and it needed more staff.
The first new hire? A workshop manager. This is your operating system. Now, the manager doesn't build anything themselves. Instead, they organize all the incoming work orders, they decide which joiner gets which task, and they make sure the warehouse stays stocked. Basically, they let the experts focus on doing their expert work. With a manager coordinating everything, it was finally time to hire more help. The first thought was to just build a whole second workshop next door. That's basically a multiprocessor system. But then, a much better idea came along. Hire more joiners to work in the same shop. That's a multi-core processor. And today, they all work as this really tight team sharing the same warehouse and tools, which makes them incredibly collaborative and efficient. All right, let's get to our final big idea. Our workshop is now buzzing with a whole team of brilliant, versatile joiners. But what happens when an order comes in for, say, 10,000 identical wooden chairs? Is a team of master craftspeople really the right tool for that job? Or is there a better way to do it? And here you can see the two completely different philosophies at play. The CPU, that's our team of master craftspeople. Each one is a genius who can handle any complex, one-of-a-kind project you throw at them. The GPU, the graphics processing unit, is something else entirely. It's a massive assembly line staffed by thousands of workers who are each trained to do just one simple, repetitive task over and over, all in perfect sync. It's not versatile at all, but for huge parallel jobs like rendering video or training AI, it is absolutely unbeatable. Just to give you a sense of that scale, a single, very popular graphics card, the NVIDIA GTX 1080, has 2,560 of these specialized cores. I mean, just picture that. An assembly line with over 2,000 workers, each one sanding the exact same chair leg at the exact same moment. That is a staggering amount of focused parallel power. So here's the big takeaway. Modern computer performance isn't just about the raw speed of one worker. It's all about the architecture of the entire workshop. It's about knowing when you need a team of brilliant generalists and when you need a massive, specialized assembly line. Understanding that layout, the craftspeople, their workbenches, and the assembly lines, that is the real secret to unlocking your computer's power. So the next time you're choosing a new laptop, or you're wondering why a video game looks so incredibly realistic, you'll have this little story in your head. You'll see the joiners at the workbenches, the manager directing traffic, and that giant assembly line humming in the background. You understand the workshop now, so the only question left is, what are you going to build with it?